Corrosion. Corrosion is an undesirable oxidation of metals. And this happens slowly, but spontaneously. Oxygen's easily reduced. Pointing at the wrong thing. Oxygen's easily reduced, so it can bring about the oxidation of other substances. In fact, that's where the word oxidation came from, is because oxygen does it the most. So oxygen plus water lost myself here. So the oxidation of most metals is spontaneous when paired with the reduction of oxygen. Yeah. Because this is the reduction. Oxygen gets reduced, the other thing gets oxidized. So metals generally are easily oxidized in the presence of oxygen, acid, and water, and yet they are still useful as building materials. Many metals will form oxides that coat the surface and prevent further corrosion. And aluminum is one that does this. So aluminum corrodes to form Al2O3, but Al2O3 is highly inert, it's structurally solid, and so it forms a protective coating on the aluminum, and then no more oxidation can occur. Iron, not so much. Oxides of iron, which are called rust, are not structurally solid. They tend to flake away from the underlying metal, and so as they flake away, they expose the metal to further corrosion. And here we have a picture of a rusty metal building. And here's an illustration of the electrochemical reactions that are happening when iron rusts. So the electrons produced by the oxidation of iron to Fe+2 in the anodic regions travel to the cathodic regions where they react with oxygen and hydrogen from the carbonic acid naturally formed from carbon dioxide in the air. This dissolved in the moisture. Then the iron 2+ ions can travel through that surface moisture to cathodic regions where they're further oxidized to Fe3+. And so the rust that we see is actually a hydrated form of iron 3 oxide. And the exact composition can vary. But in order for this process of rusting to occur, we have to have some water present here to allow the ions to move, and we have to have oxygen present. So moisture must be present in order for charge to flow, and also because water is a reactant in the last reaction there. If there are any additional electrolytes present, like salts in that water, they will promote rusting. And so we see that cars rust more quickly in cold climates where the roads are salted, or in coastal areas where there's seawater mist. So the seawater mist has salts dissolved in it. I grew up in Minnesota and Iowa where they salt the roads in the winter. And it was very, very common to see extremely rusty cars. We called them rust buckets. The presence of acids also promotes rusting because the lower pH enhances the cathodic reaction. So here's a picture of a painted surface, and when the paint gets scratched, it exposes the metal underneath, which then begins to rust. So the prevention of corrosion, especially in iron, is a big industry. Keeping the iron dry is one strategy. So you can coat the iron with a substance like paint that's impervious to water, and that works great until the paint gets scratched. Another way is to place a sacrificial electrode in contact with the iron. So here we have an iron pipe, and this is a sacrificial electrode. So we're sacrificing the metal in this electrode to save the iron pipe. So this must be something that's more easily oxidized than the iron, and so it will get oxidized and the iron will be left alone. Another approach is to coat the iron with a metal that oxidizes more easily, and so galvanized nails are coated with a thin layer of zinc. The zinc oxidizes, forming zinc oxide, which is very sturdy, remains on the nails, acts as a protective coating. Which of these metals does not act as a sacrificial electrode for iron? Well, we would need to go look at, I think I was going to put one of these in there and I just got tired. We have to go back and look at this. So if we want a sacrificial electrode for iron, these are the reduction potentials. We need something that's more easily oxidized. So something below is more easily oxidized. So something above is more difficult to oxidize, and solid copper is listed there. Manganese, aluminum, I forget what the other ones were, calcium. Those are all more easily oxidized than the iron. So copper would not work as a sacrificial electrode for iron.